Yeah, we are done with carbonyls and we are done with also what? We are done with carbonyls and alkenes we have done. No? So please write next. The third method of preparation from carboxylic acid. Okay, please write. When you are going to use carboxylic acid, then you have to use RCOOH, carboxylic acid, and the reagent that you will be used, a reducing agent, that is lithium aluminium hydride only. Okay, we cannot use any other reducing agent, because other reducing agent will not be able to reduce carboxylic acid. When you use lithium aluminium hydride, I will get RCH2OH. That means I will get a 1 degree alcohol. Okay. Now the number of carbon atoms will still be the same. Here we have R plus 1 carbon, R plus 1 carbon. If you have something like this, and they ask you how will you convert this to, so this is not 4 carbon, 1, 2, 3 carbon only. So your answer will be lithium aluminium hydride. You have seen lithium aluminium hydride in the last lecture also of carbonyls. And if you have something like this, carboxylic acid, then lithium aluminium hydride will convert it to COOH. Oh, sorry, my bad. Carbon atom and 1 OH. Similarly, if you have benzoic acid will convert it to CH2OH. Okay, write a note here. Sodium borohydride, NaBH4, does not convert carboxylic acid to alcohol. Okay, therefore, NaBH4, we say that it is a selective reagent. That means it selects something and it will react. For example, if you have something like this, I have double bond O here, and I have, let us suppose, CHO here. And here I have carboxylic acid. Okay, and I am using NaBH4. So NaBH4 will be able to reduce the aldehyde. It will be able to reduce the ketone also. That means this CHO, this carbon, 1, 2, 3, 4, 5 carbon atoms. This COH will be as it is. This ketone will get converted to OH, and this carboxylic acid will also get converted to OH. Right? You have seen NaBH4, how it reacts. All of you understood this? Yes or no? Please tell me. Guys, tell me. All of you done? Pia,
Yes,
Aliza, and Deborah, done?
Yes, sir.
Right, next point. Since lithium aluminium hydride is expensive, carboxylic acid, CAS, carboxylic acid, is first converted to ester and on further catalytic hydrogenation, we get alcohol. Okay, so RCOOH, we first of all react this with any alcohol, R dash OH. This gives us the ester R, C double bond O, and OR dash. Now, when this reacts with H2 in the presence of nickel PD or PT, as we have seen in the previous lecture, this R CH2OH, it becomes what? RCH2OH. Okay, this part. Okay, right, another point, lithium aluminium hydride can also convert esters to 1 degree alcohol. Okay. But nobody uses this method of converting ester to alcohol by using LiL4 because it is very expensive. Okay, so if you have CS3 C double bond O, oxygen, and then let us suppose you have CS3 and you are using lithium aluminium hydride. So the bond is going to break from here. The carbon and single bond oxygen is going to break, and you are going to get 1 2 carbon atom OH plus 1 carbon atom OH, CS3OH. Write this down. Let me know once you're done. Done, everyone? All of you wrote this down? Anyone still writing? Guys, anyone still writing? No? Right, next. From haloalkanes. Okay. So if you are using haloalkanes such as RX plus aqueous KOH or NaOH, I will be getting alcohol ROH. Plus I will get KX, but that KX does not matter. No? So if I have, let us suppose, 2 carbon atoms in Br, so wherever the Br is attached, the OH will be attached on the same carbon. Asna is not here today. Just a second. Similarly, if you have something like this, chlorine plus aqueous KOH, Got it, guys? Write a note. Three-degree haloalkenes. 3-degree haloalkene gives a mixture of alcohol and alkene on treatment with aqueous KOH or NaOH. Aqueous KOH or NaOH due to its bulky size. Due to its bulky size. Therefore, it is not used to prepare 3-degree alcohols. Done, everyone? See, I mean, whatever notes and remarks we are writing, oh, you're not done. Okay. See, whatever notes and remarks we are writing, you can see many questions from these, right? Y type of questions. So all of these should be there in the sheet of Y questions of alcohol, phenols, and ethers. Why is 3-degree haloalkane not used for the preparation of 3-degree alcohols? And all of these questions can be asked. Now, done. Okay. Now, please see. This is what fourth, right? The fifth one. From aliphatic primary amines. Okay. So this reaction is not there in NCERT in alcohol chapter, but it is there in the amines chapter. Okay, chemical reactions of amines. That is why I'm bringing it up here. Okay, don't think that it is not going to come in the examination. Please write it in the method of preparation of alcohols also, because it is present in the last chapter amines, RCH2 and NH2. I can write NH2 as it like this, nitrogens with 2 hydrogen. And if I react this with ONO, ONO is nitrous acid, HONO. It is prepared by reacting NaNO2 and HCl. Okay, this is prepared in C2, ONO. Now what happens in ONO? The HO, it attaches to this carbon atom, this nitrogen attaches to this nitrogen atom, and the oxygen attaches to this 2 hydrogens. Okay, so as you can see, we are going to get our CH2 OH plus I will get N2 gas plus I will get water H2 plus I will get water H2. So for example, if you have 2 carbon atoms and NH2 in the presence of ONO, we are going to get, instead of NH2, I will get OH. Similarly, if you have something like this, NH2, I will get OH like this. By the way, Fia, Deborah, did you guys watch that lecture on optical activity? Haloalkane, halorine. And also on conversion, organic conversions, haloalkane, halorine. Fia, what should I explain? Can you please turn your mic on? This reaction. What do you want me to explain, Pia? Can you please turn your mic on and tell me? Avoid chat as much as possible, guys. Okay, please avoid using chat as much as possible.
Sir, I want this reaction.
This reaction. So here we are using nitrous acid. No? So this CH2 will get attached to OH. Okay, OH will get attached to CH2. The nitrogen gets attached to nitrogen, and these two hydrogens will get attached to oxygen. So CH2 and then OH, N2, nitrogen, nitrogen, and H2O. Okay, this is the way of writing the product. There is only a replacement happening of NH2 with OH. NH2 is getting replaced by OH. That's it. Done writing? All of you guys done writing? Yes or no? Please tell me.
Yes, sir.
Yes, no? No. So we have 5 methods of preparation for alcohol. Now write next method of preparation of phenols. In this, you will write number 1 from benzene sulfonic acid. From benzene sulfonic acid. First of all, we will make benzene. First of all, we will make sulfonic acid. Okay, we will make the benzene sulfonic acid. For this, we will have to start with benzene ring. And then I will add concentrated H2SO4 in the presence of SO3 gas. Okay. And this mixture is known as oleum. Okay, the common name of this concentrated H2SO4 with SO3, it is known as oleum. When I prepare this, I will get a benzene sulfonic acid. That means benzene ring attached with SO3H. So this is what this is. Benzene sulfonic acid. After we get benzene sulfonic acid, we are going to treat this benzene sulfonic acid with NaOH. And we are going to heat it. Once we heat it, we'll get ONA. That means the sulfonic acid, it will be replaced by sodium phenoxide. And once we have got ONA, I will just use acid in the presence of water, that means H plus in the presence of H2O, to replace this ONA with hydrogen. Okay, so the Na in the phenoxide will be replaced by OH, making it phenol. This is sodium phenoxide. This is phenol. After this, we are going to look at a reaction that we have already seen in the last chapter from haloarenes. And this is one of the commercial method of preparation of phenol. So here we use a very cheap reagent, that very cheap substrate, that is chlorobenzene. And we use also a very cheap reagent. We use first of all aqueous NaOH at high temperature 623 Kelvin. And because it is commercial method of preparation, we can have chambers in which we can increase the temperature to a very large Kelvin. Secondly, I will use H3O positive or H plus in the presence of water, and I will just get phenol. We have done this reaction in the last chapter also. This process is called, is AKA also known as Dow's process. After halogens, right next, third one. From benzene disonium salt. Now, in the last chapter, we saw that benzene disonium salt can be prepared by treating aniline. That means benzene with the presence of NH2. We are going to treat this aniline in the presence of what? ONO, that is prepared by mixing NaNO2 and HCl. NaNO2 plus HCl at 0 to 5 degrees Celsius. We will be getting benzene disonium chloride, N2 positive and Cl negative. On warming this in water, we will get phenol. So the disonium group is replaced by hydroxide OH. This is aniline. Right, the fourth one. The fourth one is also a commercial method of preparation. From cumene. Cumene is nothing. Cumene is isopropyl benzene. Okay, cumene is isopropyl benzene. Just give me a second, guys. And isopropyl benzene, please write. First of all, we'll see how to make isopropyl benzene. For this, you will need benzene ring, and we will do a Friedel-Crafts alkylation reaction. We'll add an alkyl group. Okay, benzene plus CH3, CH3, and a chlorine here. We'll use AlCl3 as a catalyst, and this will give us. See, the chlorine is removed from the middle carbon, so the benzene will attach to the middle carbon. CH, CH3, and CH3 here. Okay, now this is cumene or isopropyl. Cumene or isopropyl benzene. Now, we will take this cumene, that means benzene, that is attached with isopropyl group. We have carbon atom, hydrogen atom, CH3, and CH3. We will react this with a very cheap material, oxygen gas, that is readily available in the atmosphere. This oxygen, it does an insertion reaction and it inserts between the carbon and hydrogen bond like this. Here we have CH3 and here also we have CH3 as it is. Now, once you heat it a bit in the presence of water and acid. Then there is a migration happening. So this oxygen atom it attach on this particular carbon, and this is broken. This part is broken on heating with water and acid. And when this part gets broken, I will get phenol. So this OH, it shifts here. OH shifts here, and plus I will get CH3 bonded to carbon. This carbon bonded to CH3 and double bond. Okay. Is everyone done? So as you can see, this is phenol, and this is acetone. I will see acetone in the next chapter, that is aldehyde ketones and carboxylic acid. Okay. So both of these are very useful materials. Please write, phenols are commercially prepared. Phenols are commercially prepared using cumene as the reagents are inexpensive, not very expensive, and the products formed and the byproduct acetone is useful material, useful substance. All of you done writing?
Sir, what is written after inexpensive and?
And the byproduct, that is the THC.
Okay.
All of you done? Yes or no, please see me. Done. So we have done the method of preparation of alcohols and phenols. Okay. So you are going to now make a sheet in which you will be having MOP of alcohol, right? In MOP of alcohol, you are going to write a few things. First of all, you will write alkene. And in alkene, you have two methods, H2O in the presence of H plus, which gives you addition in the Markovnikov way, right? And then we have what? We have B2H6, that hydrogenation oxidation, it gives you in anti-Markovnikov addition. Then we use aldehyde and ketones. So aldehyde ketones, you have two method reduction. In this, aldehyde gives 1 degree and ketone gives 2 degree alcohol, right? And after that, we use Grignard reagent, right? Grignard reagent, HCHO formaldehyde gives you 1 degree. If you have any other RCHO, any other aldehyde, that gives you 2 degree. Then ketones will give you 3 degree. After that, we have seen carboxylic acid, RCOH. So in this, we can only use what? Only LiAlH4. And then an important point regarding expensive, that is why RCOH is converted to esters, right? And after that, we have seen RCOOR, that means esters can also be used. For this, we can use H2 in the presence of nickel, PD or PT, right? And we can also use LiAlH4. Then we have seen RX, haloalkene. In haloalkene, we are using aqueous NaOH or KOH, and then 3 degree is not prepared. 3 degree is not prepared. Then we have seen RNH2. In this, we get 1 degree alcohol. Okay, so please write all of the method of preparation in one page. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, after this, please write the topic physical properties of alcohols.
Sir, can you scroll up?
You want to take a screenshot? Take a screenshot.
Yes, sir.
Done?
Yes, sir.
Write physical properties of alcohol. Okay. First of all, right, regarding the physical state. You will just read through this physical state. Whenever you revise, you just read through it. No need to memorize it and no need to understand many things here. These are just facts that can be asked in MCQ or something. Okay, so you have to remember those facts also. At least they should be there in your notebook. So if you remember something, then you can plug in the answers. Okay, so please write number 1. Lower number of lower alcohols, lower member of alcohol. Lower member of alcohol are colorless liquid. Are colorless liquid with characteristic smell. Okay, right, next. Alcohols with more than 12 carbon with more than 12 carbon atoms are colorless solids. Right, next. Phenols are crystalline solid. or liquid. Now, crystalline, solid, or liquid phenol, it depends on the way of preparation. Okay, or liquid and have phenolic smell and have phenolic smell. All of you done?
No, sir.
Let me know once you're done. Second, we will look at boiling point.
Done, sir.
In boiling point, please write. First point. Alcohols have higher boiling point as they have hydrogen bonding. As they have hydrogen bond. How? We see you have alcohol R bonded to O and then it is further bonded to H. Similarly, there will be some other hydrogen which is bonded to oxygen, which is further bonded to R2, right? So this oxygen atom, it will be pulling electrons from the hydrogen atom because it is more electronegative. It will be getting delta negative charge and the hydrogen will be getting delta positive charge. Similarly, delta positive charge will be there on hydrogen of this particular alcohol and delta negative on this oxygen atom. And also the oxygen atom, they contain lone pair electrons. So these lone pair electrons can also take part in the bond formation with hydrogen. This is hydrogen bond. So delta negative and positive, they will form bond like this. Right, they will form bond like this. So this is the hydrogen bond. You'll write next. Since alcohol have hydrogen bond, their boiling point is greater than that of non-polar. Okay, non-polar क्या क्या हो सकते हैं? Ethers, alkane, etc. And non-polars and polar. What can be polar? Haloalkane, aldehyde, ketones. Okay, all of these can be, and both of them, it is greater than non-polar as well as polar molecules. So what we can say in terms of boiling point, first thing that you will see is the force of attraction. And if I talk about the force of attraction, then the highest force of attraction is with the hydrogen bonded molecules, followed by polar molecules, followed by non-polar molecules. Let me know once you're done. Anyone still writing? Anji guys, anyone still writing? No, right? Okay, fine. Right, next. Boiling point of alcohols increases with increase in carbon atom. Increases with increase in carbon atom due to increase in molar mass and van der Waals forces. Okay, so if I have CH3OH, one carbon atom, this will be having less boiling point than two carbon atoms OH, less boiling point than three carbon atoms OH. The fourth carbon atom OH will be having even more boiling point, and so on. Got it, guys? Yes or no, please tell me. Okay, after this, you will write boiling point of alcohols decreases with increase in branching due to decrease in surface area. Okay, so if I have five carbon atoms, let us take four also. 1, 2, 3, 4 carbon atoms and OH. This is straight chain. And if I increase the branching, so OH here, as you can see, the branching has increased. I can increase the branching even more. Here also we are having 4 carbon atoms and 1 OH. You can increase the branching even more, 4 carbon atoms and 1 OH here. So as you can see, the surface area is getting smaller and smaller. So there will be not too much of polarity there. Okay, so here you can see delta negative is here. Delta positive, large delta positive will be here. So a large dipole will be created. That large dipole is not created in this part. Okay, when you have more branching. So this will be having highest boiling point, followed by this and followed by this. Okay. So first of all, you are going to look at boiling point as directly proportional to, see how we are going to compare. First of all, you will compare. Number one thing is boiling point is directly proportional to FOA. And this has hydrogen bond. After that, polar. After that, non-polar. Secondly, you will see boiling point is directly proportional to molar mass. Thirdly, after that, if molar mass is also same, then you will look at the branching. And it is inversely proportional to branching. Got it, guys? Yes or no, please tell me. हाँ जी बताएं. All of you got this?
Yes, sir, understood.
Understood now? So first of all, you will see
Yes.
force of attraction, then molar mass, then branching. Okay. Write a question. Arrange the following. In increasing order of boiling point. Increasing order of boiling point. A is pentane 1-al. B is N-butane. C is pentane 1-all. D is ethoxyethane. First of all, make the structures and send the answers. I mean, at least make the structures and then send the answers on my WhatsApp. Okay. Take 1, 2, 3, 4. No, take 2 minutes for this. Guys, send the answers, at least the structures. Send me once you're done. Or rather, take 1 more minute. If I got your answers. Without even structure, you are telling me the answers. See, there's a mistake. You have to draw the structures, otherwise you are not going to get the right answers. Okay. So please here, guys, pentane 1-al. 1, 2, 3, 4, 5 carbon atoms, and Al is for CHO. Aldehyde. And butane. Butane is just 4 carbon atoms. Okay, my bad. Wait a second. Pentanal, no? 5 carbon atoms and CHO. Yeah. Butane is 4 carbon atoms, right? After that, you are going to look at pentane 1-all. 1, 2, 3, 4, 5 carbon atoms, and then OH. Ethoxyethane is oxygen with 2 carbon atoms here and 2 carbon atoms here. Now, first of all, you have to look at the FOA, force of attraction. Deborah, you revised the lectures of IUPAC nomenclature. You don't know what is IUPAC nomenclature, okay? So you please revise those basic organic chemistry lectures. Otherwise, you will be struggling in the complete organic chemistry, molecular having alcohols, phenols, aldehyde, and amines. There is no substitute of IUPAC nomenclature. There is no substitute. If you are not putting in the hours, you will not understand it. You are not going to get it just by doing organic chemistry. Reactions, you can get it just by doing chemistry. IUPAC nomenclature, you will not get it. Okay. So spend like 1 or 2 days completely on IUPAC nomenclature and get it done. Now, so first of all, this is aldehyde, this is butane, and this is ol, and this is ethoxyethane. So first of all, I will classify them into hydrogen bond, polar and non-polar. So pentane 1-ol, obviously it is having hydrogen bond because it is alcohol. Then ethoxyethane, it is an ether, it will have slight polarity, right? Slightly polar, it is approximately non-polar, okay? It is approximately non-polar, but it is having slight polarity more than that of butane. This is completely non-polar because there is no polar bonds here. Here we have slight polarity because of the lone pair of oxygen atoms, okay? Slight polarity. It is weak polar, I will say, weakly polar. And this pentane 1-ol, CHO, if you look at the CHO carbon, this is having double bond O and hydrogen here. So obviously this oxygen atom is what, delta negative. There will be a polarity in this pentanal and it is a polar molecule. Now, if I look at only these parts, then I can say this is A, B, C, and D. I don't even have to look at any other thing. Only by looking at the force of attraction, I can say C's will be having the greatest. Now, followed by which one? The non-polar or the weakly polar? Obviously, the weakly polar D. After that, we will, sorry, my bad. After hydrogen bond, there will be polar, that is A, not D. After A, there will be D, weakly polar, and after that, we will have the non-polar B. Now, also, even if you keep this as non-polar, okay, so NCERT has, this question is in NCERT, even if you keep this as non-polar, the molar mass of butane is less than ethoxyethane. Why, sir? Because here we are having only 4 carbon atoms. In ethoxyethane, we have 4 carbon atom plus 1 oxygen atom also. So if I look at the molar mass, then also B kar diya, this will be D and then B. Then also the D1 will be having greater boiling point than the B. Ethoxyethane will be having greater boiling in terms of polarity also and in terms of the molar mass also. Is that clear? Yes or no? Please tell me. Pia, you understood this part?
Yes, sir.
Okay, so you have to make the structure. If you don't make the structure, you will not get the correct answers. Right, next. Right here, pentane 1-ol, comma butane 1-ol, comma butane 2-ol, then ethanol, then you will write propane 1-ol, and then you will write methanol. Okay, so write the structures for this. I will still give you, take 4 minutes for this. Send your answers once you're done, guys. Okay. Not the answers, just send the structures first of all. Once you get these structures, then you can apply the concept of boiling step by step. Structures first of all. Aliza has sent some pentane one all. Pentane all. Okay. 1, 2, 3, 4. Fine. 1, 2. Fine. 1, 2, 3. Yeah, correct. Very good. Pia has also sent here. Pia 1, 2, 3, 4, 5. Fine. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2 ethanol 1, 2, 3. And then methanol में CH3OH कर दीजिए Pia.
Yes, sir. If I write like this, it's wrong.
Not wrong, but it may be confusing to some people. Okay.
Oh.
Because
But
see,
this is okay, right, sir?
but we don't really write it like that. You see that if I
Okay,
write
sir.
this, some may see that what is this? It's like OH is attached somewhere, right? So it is better if you write CS3. There's only one carbon atom. The bond line structure that we write, it is only to save time, and we should save time, and it should not bring some ambiguity or vagueness. Okay, so CS3OH is not, obviously it is not going to take much time. Okay, so it is much better than this, because this may be vague. No, some may not understand it, and we are not seeing much time by writing dash OH. Okay, so that is why we have to optimize things. Now in pentanol, Deborah, I see that you don't write the OHs. I mean, things are fine, but you forget to write OHs. Seems like that. So pentane means 5 carbon atoms, 1, 2, 3, 4, 5, and then OH. Butane 1 all will be 1, 2, 3, 4 carbon atoms and then OH. Butane 2 all 1, 2, 3, 4 carbon atoms and then OH. Ethanol will be 1 and 2 carbon atoms with OH. Propanol will be 1 and 2 and 3 carbon atoms with OH, and the methanol will be CH3OH. Now let us suppose we have this A, this is B, this is C, this is D, this is E, and this is F. Now first of all, you are going to look at D. First of all, अरे आपने delete क्यों कर दिया? Deborah and Fia? Fia, am I audible?
Yes, sir. It was by mistake.
You cannot kick it by mistake. How can you?
No. While viewing it, I just did by mistake.
No
While
problem.
viewing it.
I'm just. Have you not seen that meme? That meme is there now. You cannot kick it by mistake. What, Pooja? What is this behavior? You have not seen that. Aliza, you have seen.
It's not. It was by mistake, seriously.
Sorry, what? You have seen that meme or not seen that? Not seen that. Aliza, आपने देखा है? Yes, Aliza.
No, sir.
नहीं देखा आपने?
No.
अरे इतना फेमस है. पुराने बिग बॉस में आता आया. I mean, I have not seen Big Boss, but I've seen that. A girl was there. She kicked a dustbin, like जानबूझ के ऐसे kick कर दिया उसने. And then it fell. Then the other participant, she was like, Pooja,
Okay,
what is
sir.
this?
Yeah, I
behavior?
saw that one.
हाँ देखा ही होगा. चलिए तो अब चलते हैं यहाँ पे. And first of all, what we are going to look at, see, sequence में है ना, बिल्कुल sequence. First of all, force of attraction, hydrogen bond. See, all of them are alcohol, so all of them are having hydrogen bond. We don't need to compare hydrogen bond. Then next we have molar mass. So molar mass is directly proportional to the number of carbon atoms. So here we have how many carbons? Here we have all of them are having OH. So we don't need to consider OH right now. Okay. So here we have 1, 2, 3, 4, 5 carbon atoms. Here we have 4 carbon atoms. Here we have 4 carbon atoms. Here we have 2 carbon atoms. Here we have 3 carbon atoms. Here we have 1 carbon atom. Now, in terms of carbon atom, I can say that A will be having the highest boiling point, followed by B and C. Now, when I going to compare B and C, both of them are having 4 carbon atoms. Now we are going to look at which one is having less branching. Once we are done with molar mass, that is the number of carbon atoms, I will move to branching. If the carbon atoms are same, so which is having less branching? So B is having less branching. So after A, we'll have B. After B, obviously we'll have C because 4 carbon atoms. Then we will look at the 3 carbon atom, that is E. Then I will look at the 2 carbon atoms, that is D. At last, we are going to write for F. Can you see how crystal clear things are when you write it in terms of like level wise? We are not seeing force of attraction because all of them are what? OH. Then we looked at the number of carbon atoms. When we had a tie, we moved to the next point, that is branching. So I will write here. This was decided by the branching criteria. Branching. Is that clear? Yes or no? Please tell me.
Yes, sir.
Too much work. Yeah.
Yes, sir.
Is this too much work?
No, it's understood, sir. It's clear.
Understood, no? It's clear. Okay. So right next and the last physical property, that is solubility. Third part. All of you understood, na? Aliza and Deborah?
Yes.
Okay. Do these problems once again while revising, okay? Solubility. Please write alcohol and phenols are soluble in water due to their tendency of forming hydrogen bond with water. Hydrogen bond with water. Please see, we have ROH and we have HOH. So obviously here we'll have delta negative, delta positive, here delta positive, and here delta negative. Because of electronegativity differences, there will be hydrogen bond between oxygen and hydrogen and oxygen, like this. So alcohol and water molecules are interacting with what? They're interacting with hydrogen bond. That is why they are soluble in water. Now, in this hydrogen bonding, please see, we have two parts in alcohol. One is R and the other one is OH. One is R and the other one is OH. As you can see, the OH part is taking part in solubility, right? It is something that is favoring solubility. OH part is making the alcohol soluble. So this is responsible for soluble. I will say it is favorable for soluble. Favorable for solubility. But if I look at the alkyl group here, this alkyl group, please listen very carefully, don't write anything. This alkyl group, it is not taking part in the solubility. Is it having any contribution on solubility? Tell me, guys. Is it making any hydrogen bond with water? Is the R group, alkyl group, making any hydrogen bond with water? Yes or no? Tell me. Aliza, Deborah, Fia. Look at the hydrogen bond that we have made and tell me. Is it making any hydrogen bond with water? Aliza, Deborah, Fia.
No,
R
sir.
group. Alkyl group is not forming any hydrogen bond, right? That is why this alkyl
Yes,
group,
sir.
it is not favorable for solubility. So it is unfavorable. Not favorable for solubility. And if you are going to increase the not favorable part, then the solubility will decrease or increase. Tell me, guys. If I increase the not favorable part, if I increase the alkyl group, then the not favorable part will increase and the solubility will?
Yes, sir. Decrease.
Solubility will decrease, right? So please write. On increasing the number of carbon. Aliza and Deborah, you guys are not answering. Was it not logical? On increasing the number of carbon atoms in alkyl group. Yes, Deborah and Aliza. of
Yes,
alcohol.
sir.
You understood this part, yes or no?
Yes, sir.
Yes, sir.
Hope so. Carbon atoms in alkyl groups of alcohol, the solubility decreases as the larger alkyl group prevents the formation of hydrogen bond with water. So therefore, solubility, CH3OH will be most soluble, followed by the 2 carbons OH, followed by 3 carbons OH, and so on. Right, next. In isomeric alcohols, the boiling point increases on increase in branching as the surface area decreases. If I have 4 carbon atoms, 1, 2, 3, 4, OH, 4 OH, 4 carbon atoms and OH like this, 4 carbon atoms and OH here. So as we are increasing the branching, as you can see, here we have a very large group which is going to interfere with water molecules and not make any bond. But as we are increasing the branching, what happens, the surface area of the molecule, it decreases. So here we have, this is the molecule. And this much part is not forming any hydrogen bond. But right now, this much is the molecule and only this much part is not. So almost half it is, it looks like almost half of them is forming hydrogen bonds. Okay. That is why this will be having the least, followed by this, and then followed by this. So as we increase the branching, what is going to happen? The surface area is going to decrease and the boiling point is going to increase. And right, the last point, insolubility, phenols are less soluble. Phenols are less soluble than alcohols, due to bulky benzene ring. Write this down. Let me know once you are done.